start at this end or this end? Right. Oh, no, left.
No, because no one ever bought it. See, she's like the clothes on her side. If you go there, she never bought it.
What is this called? So remember, substitute ends in O, right? Methyl, and then complex. What was the longest chain for the complex? For complex, we take the first letter of the base name when alphabetizing, so B and butyl, and then for these and then all together it should be 4, 1, 3, dimethyl butyl, 6 cyclohexyl, 3 alcohol, 2 9-dimethyl, Jack, and then what's the numbering for the double bonds?
37.
Diene, yeah. Because there's 2. The name is good, right?
Why is it all because
What was the question?
Why 4 first? Because butyl comes first.
Yeah. Next was stereoisomerism. The first one was were they different? Same conductivity. For this one, it's like converting it, so if I'm getting it from that side, OH. The ones towards me are hydrogens. And then Br, and C. And then we number by atomic number, right? First, the chiral hydrogens. Keep it consistent. for this one, which one's first? Highest atomic number? For this one, or and then CBR. And then that's 1 to 2 to 3 is S, but the lowest is on a wedge towards us, so we change it to an R. And then for this, is it R?
Yeah, it was.
Oh my god. Clockwise R, and then for BR, or this one, for this car, BR is first. And then CCL, example, and IPP. 1, 2, 3. This time it's complicated, but hydrogen on a wedge. R.
For that one, when you draw it this way, hydrogen should still be on dash.
Yeah.
Hydrogen?
Yeah, if it's the back one, hydrogen should, if hydrogen's on any one of those three, it's always facing away from you. So you can trust your numbers, you don't have to reverse it.
Oh, when I converted this, I was viewing it from this angle. So like,
I see.
yeah, so imagining that these two are towards me, yeah.
That's the eyeball.
Yeah, exactly, that's the eyeball. That's an eyeball, guys.
Your eyelashes.
This one's SR. And then for this one, same thing. So this one's SS, right? Which makes these diastereotypes, yeah. Because one is different, right?
So, question, can there be something that is SR, and that would be same, right?
Yeah, that'd be same.
Okay, so if you look, okay, and if SR and then if RS is a non-zero or something like that.
That's, yeah.
Okay. Thank you. So basically for that system, because like I didn't memorize the whole like table for like.
One will be different, one will be the same. So SS are the same, RS are different, yeah.
Thank you.
Also, thanks, Yesley, for the colored chalk. Next one.
What did you get? Diastereotype?
Yeah,
And it was SS, right? Second.
yes. There's one chiral. For this one, since the CL on the dash, you can see the hydrogens on the left. This one's the OH is on the right, so the hydrogen is on the dash. Here, CL is up, equatorial, hydrogen is down axial. Okay, for numbering, Cl is gonna be 1, and then this carbon is closer to this group, so it'll be 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. That's all. Hydrogen's on a wedge, so S. S. Hydrogen's on a dash, so we can keep it as One, two, three. Clockwise, but it's down, so that's away, so we can keep it the same. And this one is counter. It's up towards us, so we change it to R. Yes. Did everyone get that right?
I didn't even do none of that. I just saw that OH in this one is going up, and then in the chair confirmation is going down. So I was like, it cannot be the same. It cannot be diacetyl because they're both trans. So I was like, it must be an outsource.
Okay. If that worked for you, then shortcuts.
But then you get to the third one, and then that's like, whoa. Wait a minute. So I think I'm correct.
Last one.
So, they were the OH makes it
And then we can also draw in the hydrogen. What did we notice about this one? Not the same connectivity, right?
Yeah.
So let's see. This has carbon, carboxylic acid, CH2, CH3, and hydrogen. Carboxylic acid, chlorine, right? So it's different. So these are constitutional.
What was that? I knew it was something else. It's just like,
Wait, can you explain why, like, one more time?
Yeah. Let me write it out actually. So the groups for this chiral center are CH2, CH3, COOH, and hydrogen, right? And so the other one is Cl, Me, hydrogen. Over here is Cl, COOH hydrogen, and CH2, CH3, and they'd be different if, one of them had like a completely different atom than that one.
Yeah,
Yeah.
or something.
Yeah.
Well, wait, how would you call, how would the COH, which one would be the one?
Oh, this is COOH.
So that's like the whole,
It's gone.
This and this are the same.
so it would be like, if we were to like put it, that would be, that whole thing would be one.
Yeah.
This one's right next to it. This one's off.
Okay, well, like,
This one we can see.
Yes.
Yeah, but then this actually should be this right here, so it should be next to the issue.
Okay, for this one, this is small base, and tertiary, right? Tertiary substrate. So, E2, is that so? But what's different about this one?
Wait, I got a question. What is tertiary?
The VR.
Yeah, but what is?
So 1, 2, 3.
Oh,
But this is a stereo specific question. Which means that while xi sub you would want it to be here, the hydrogen needs to be opposite of the VR. So the VR is on a wedge, the hydrogen needs to be dashed. But this hydrogen is also on a wedge. So we can, yeah.
Why can't we put it under the VR? Isn't that also force substitution?
Under the
Because
VR?
that would make the state
If I
under.
put the pi bond over here, this is one.
This carbon has more than 4 bonds.
Oh,
Yeah.
okay, thank you.
Yeah.
And then this is CH2, CH3, right? So this has a wedge hydrogen and a dash. So we're gonna do the attack this beta ion. So this base is gonna attack here. It's gonna form a pi bond there, and then the leaving group is gonna leave. So it'll look like this.
Yeah. We gotta do it twice. Where's the water? The second part.
And then what's this on the table? Yeah, anti-mark addition in VR. So is it gonna go here or here? If it's anti-mark,
The mark is gonna be the base of the top side.
top right? Okay, HBr without the ROR is 1, and also rearrangement possible, right? So, first we'll coordinate. It'll never go on the primary side, so it'll be are is tertiary, small base, side set. So where is the double bond gonna add to be the most substantial? Here, right? Okay. This one was, I think, from one of the previous exams.
Yes.
So this is, well, heat, so immediately we know it's T2 Hoffman. Here or here? And oxidative cleavage, so we're just gonna cut it in half.
It was like a house.
Yes, she did. She showed us.
Okay, alcohol, acid, E1. Protonate, OH.
No, I'm saying like E1 does have a revolution possible.
We're protonating because OH is a bad leaving group, so we want to make it water. Yeah, so that it leaves. So then we become OH2 plus. This way we can- What can we shift? One of the hydrogens from here, right? And then E1's always side sub. So when will the double bond form? Here, right? Yeah. And this is halogen. Is it? Or-
No.
Yeah, halogen. Anti-addition. So one will be on a wedge and the other on a dash.
But wait, continue, where do you want the, like, how do you go from the third to the fourth?
This to this?
Yeah.
Okay.
This was completed.
So we have our carbocation here, right?
Yeah.
And then we wanted to form side sub.
Yeah.
So
The
there's
side-
hydrogens here, there's hydrogens here.
Mhm.
And we're gonna choose this one, it'll form the double bond.
With the most systems, yeah.
Yeah.
No, I think that's all that was just with acid base.
When you're forming as a robot, do you have to show arrows for it?
No.
Since it was opposites, I mean, it was trans, I think that's two opposite sections. So I put it up, down, up, down, and then up, down, down. I forgot that. For both of them, that was four ones. Two points. Four, that's what we said. 1, 4,
swap them, right? ER for OH. Again, alcohol, acetate, E1.
But it's essence to the middle one, right?
Yeah.
So it's just change it. Also,
Again, we're gonna put it in.
is this
OH2 plus. This will leave. We have this. What can we shift? Hydrogens. And then NITSUB, so we want it on here or here? At the end or in between?
Just a question is, in the first one, the first step, what is the reason you go to the right, with the addition, like you don't go to the left? I just want to make sure.
For anti-mark,
Yeah.
VR is gonna add to the less substituted side. Yeah. For mark, more.
Oh.
My correction.
I think I'm good, I just need to stop second this.
That's what I like to hear.
Oh. Yeah, this.
Yes.
Okay, first mechanism.
Is it okay if I take the shots?
What was that? Take a what? Oh, yeah. Perfect. Okay, for this one, what do we notice? We have a 5-carbon ring that turns into a 6-carbon ring, right? So that indicates we'll have to do an alkyl shift. So I'm gonna protonate double bond. Carbon cation.